Rock properties are very complex. Yeah? On long time scales, rocks in the earth deform like a fluid, like a viscous fluid, like honey. But on shorter time scales, they behave elastically, or sometimes they break and rupture and make a fault. And all these processes can be simulated with LaMEM. And we have been using this for many of these processes in the past. My name is Boris Kaus. I'm a professor at the University of Mainz in Germany. In GES, I'm mostly responsible for the code LaMEM, which is used for simulating geological processes. Geological processes are mostly relatively slow, take millions of years, and therefore using physics-based computer models is one way to understand the past and perhaps predict the future. And that's what we are trying to do with this software. I started developing this in 2007 because at the time we wanted to write a parallel 3D code, or a 3D code that requires this to be run on big parallel machines. And this has undergone many evolutions. It originally was a finite element code, now it's a staggered finite difference code. And with time it has also been completely rewritten, so it is much more efficient. In the code you basically give an initial geometry and rock properties, and then let it run forward in time, and then it will show you how things develop. For example, how plates collide, how mountain belts form, or how other geological processes work. Yeah, so the code itself is applicable to everything that deforms very slowly. And that is a surprising large range of processes, from groundwater flowing through rocks on a micrometer scale to the deformation of a whole planet, or the planetesimals, how they collide and mix and deform. But we're also using this for very applied questions. Geomechanical questions like flow of groundwater through fractured rocks, or even the long-term stability of nuclear waste repositories in Germany, because the law says that a future nuclear waste repository needs to be safe for 1 million years. That sounds nice in the law, but how do you prove that? And one way to prove this is by using our expertise or the simulations over the last few million years and simulate it into the future. Certainly at the moment one of the easiest softwares to install. We have worked quite a lot on that, and now you can just open your laptop, you say add LaMEM, and it will install everything and will work in a few minutes on your machine. And it's also very easy to use thanks to having a Julia interface that makes it quite easy to set up a model, run a model, collect the results. The code users are to a large extent research groups at different universities that use it for simulating a whole range of geological processes, from the formation of fault zones at the mid-oceanic ridge, subduction processes, collision of tectonic plates, so large-scale processes. We have also used it to look at the dynamics of salt tectonics and salt domes. So within GES we are planning to use LaMEM to start looking at the flank of the Etna. The southeastern flank of Etna is actually moving down with a few centimeters per year into the Mediterranean. This is a process that is happening over many years, so there is no direct risk that it will immediately collapse, but it would be good to better understand how this is happening and why this is happening.